Many people were mistaken about the differences of heat and temperature. Do you know the difference between the two?
Well, in physics, heat is energy that spontaneously passes between a system and its surroundings in some way other than through or for the transfer of matter. When a suitable physical pathway exists, heat flows spontaneously from a hotter to a colder body. Because heat refers to a quantity of energy transferred between two bodies, it is not a state function of either of the bodies, in contrast to temperature, and it is measured. On the other hand, temperature is an objective comparative measurement of hot or cold. It is measured by a thermometer. Several scales and units exist for measuring temperature, the most common being degrees Celsius, degrees Fahrenheit, and, especially in science. Now let us first dive into the topics that needed heat, as its component. These are linear expansion, volume expansion, and calorimetry.
Why does matter usually expand?
Particles in liquids, solids, and gas can feel the presence of other neighboring particles. These particles are like balls that would not just stand there when heated. When an object is heated, these particles gain kinetic energy which makes the object expand.
Linear expansion is the change in length measurement of an object due to thermal expansion. It is related to change by a linear expansion coefficient. It is the fractional change in length per degree of temperature change. The formula for linear expansion is, delta L over L, is equal to alpha, delta T, where L is the original length, measured in meters, delta L is the change in length, measured in meters, delta T is the change in temperature, measured in degrees Celsius or Kelvin, and alpha is the linear expansion. The volumetric thermal expansion coefficient is the most basic thermal expansion coefficient. Illustrates that, in general, substances expand or contract when their temperature changes, with expansion or contraction occurring in all directions. Such substances that expand in all directions are called isotropic. For isotropic materials, the area and linear coefficients may be calculated from the volumetric coefficient, which is beta, is equal to 1 over V, times dV over dt, where V is the volume of the material, beta is the volumetric coefficient, and dV over dt is the rate of change of the.
For example, in linear expansion, a concrete railroad tie has a length 2.45 meters on a hot, sunny 35 degrees Celsius day. What is the length of the railroad tie in the winter when temperature dips to -25 degrees Celsius?
First, find the change in the tie's length using the formula, delta L equals alpha, multiplied by the original length and delta T 12 times 10 raised to -5 per degrees Celsius, times 2.45 meters, times -60 degrees Celsius. Then, you can find the railroad tie's final length, using the tie's initial length and its change in length. Delta L equals final length minus original length. Then solving for the final length, will give us final length equals original length plus change in length. Add 2.45 meters to -0.0018 meters, which is 2.400.
To further understand volume expansion, here's an example. A glass of water with volume 1 liter is completely filled at 5 degrees Celsius. How much water will spill out of the glass when the temperature is raised to 85 degrees Celsius?
In this situation, both the glass and the water within will expand as the temperature rises. You can treat both the glass and the water as a volume expansion. Start by finding the expansion of the water. Using the formula delta V equals beta, times original volume, times the change in temperature. Substituting the given, 207 times 10 raised to -6 per degree Celsius, times 1 liter, times 80 degrees Celsius. The change in volume would be 0.017 liters. In a similar fashion, you can find the expansion of the glass, multiply 27 times 10 raised to -6 per degree Celsius, by 1 liter, times 80 degrees Celsius, which is equal to 0.002 liters. The amount of water spilling out, is equal to the difference between the water's expansion and the glass's expansion, or 0. Calorimetry is the science associated with determining the changes in energy of a system by measuring the heat in the surroundings. In calorimetry, a device called the calorimeter is used to measure the quantity of heat transferred from one object to another. There are two types of calorimeter, the coffee cup calorimeter and the bomb calorimeter. First off, the coffee cup calorimeter. Water will change its temperature when it gains or loses energy. The quantity of energy gained or lost is given by the equation heat of water is equal to mass of water times calorimetry of water times change in temperature of water. But what if an attempt to determine the specific heat of fusion of ice using a coffee cup calorimeter, then an assumption of the energy gained by the ice when melting is equal to the energy lost by the water. Heat of ice is equal to the negative heat of surroundings, which is also equal to negative heat of calorimeter. The next type of calorimeter is called the bomb calorimeter. This is the calorimeter used to measure the heat exchanges associated with chemical reactions, especially combustion reactions. In this calorimeter the volume inside doesn't change. Heat of volume is equal to C times delta T, where C is the calorimeter constant and delta T is the change in temperature.
For example, a 2.15 grams cashew nut is burned. The heat released raises the temperature of a 100 grams sample of water from 18.2 degrees Celsius to 31.5 degrees Celsius. The mass of the nut after the experiment is 1.78 grams. Determine the calorie content of the nut in calories per gram. Assume that the water is only able to absorb 25% of the heat released by the burning nut, given 1 calorie equals 4.18 kilojoules.
Using the formula heat of the water equals mass times specific heat times change in temperature of water. Multiply 100 grams times 4.18 joules per gram per degree Celsius by the quantity 31.5 degrees Celsius minus 18.2 degrees Celsius. The heat of the water would be 5.5594 kilojoules. To find the calorie, use the idea that 1 calorie equals 4.18 kilojoules, and that would give us 1.356 calories. Since the energy absorbed by the water is 1/4 of the energy released by the nut, we will divide negative 1.356 calorie by 0.25, giving us a calorie of negative 5.4238. This 5.4238 calorie of energy was released by burning 0.37 grams of the cashew. To determine the calorie content on a per gram basis, the calorie to gram ratio must be determined. Calorie content equals 5.4238 calorie divided by 0.37 grams equals 14.66 calorie per gram. Rounding to two significant figures, the calorie content equals 15 calorie per gram.